All right, 1.5, number 9. Ooh, we're doing this one in red. You guys gonna be able to handle it? Too exciting, freaking out. All right, 1.5, number 9. All right, so this one is definitely tricky. So it says an object is dropped from rest. How long will it take to fall? And then it gives you some distances, right? So in keeping with what I've been saying, make a drawing, right? So here's your object. At time 0, because it's being dropped from rest, I automatically know that the velocity starts at 0, right? Okay, and then it's going to fall, right? Okay, in part A, it tells us that it has fallen 4.9 meters. So, what? Delta x equals 4.9 meters, and the question wants to know what the time is to get there, right? Okay, so let's write down what we know about that time interval. We know that our initial velocity is 0. We know our displacement is 4.9 meters. That feels like not enough to go on. We're looking for the time. I guess I can write that down. What else, you guys? Yeah, we know the acceleration, don't we? Because it's being dropped, right? So it's in free fall. So our acceleration here is negative 9.8 meters a second squared. Everybody good up to there? All right. So now that we've got, do we know our VF? We don't, do we? We don't know what the velocity is when it gets to this point. All right. So now our question is, which of our equations, which I should have written on the board over there, which of our equations uses those 4 variables? Well, I believe this guy does. Right? So plug in your numbers and then solve for t. All right, so let's do that. Plug in your numbers and solve for t. So let's see, our displacement is 4.9 equals 1/2 of negative 9.8 times t squared plus 0 times t. Everybody good up to there? All right, the 0 times t goes away. So now I've got 4.9 equals negative 4.9 times t squared. Divide both sides by negative 4.9, and you get negative 1 equals t squared. How do you solve it? Take the square root. I. The answer is I. No. You can't take the square root of a negative. We must have screwed up somewhere. Anybody see where I messed up? So do you guys see, first of all, does everybody see there's a problem here? Something's wrong. You can't take the square root of a negative. Just make it a positive. So in this instance, that turns out to work. It will not always, though. So let's figure out where the problem is. So write out your givens, and then, this is a thing that I'm bad about modeling, go back and check your signs. How come the acceleration is negative? Because the velocity is decreasing as it falls, right? Initial velocity is 0. Talk to me about displacement. It's going to go down 4.9 meters. So that displacement should have ought to been negative, which means that this is negative, which means that this is negative, which means that's positive, which means that positive, and we get t equals 1 second. All right. Problems up to there. All right, and then parts B through E are the same thing, except your displacement is different, right? Everybody good or no? All right. Even if you got this right, I need your attention here for a minute, please. Everybody look up. All right. So in this problem, for those of you who are not following along, here's what we just did. We used this equation to calculate the amount of time that it took to go through some displacement. And the algebra wasn't bad, because our VI was 0, right? What if VI had not been 0? What would you have to do?
Quadratic.
You'd have to use the quadratic formula, right? Negative b plus or minus the square root. All right, raise your hand if you like the quadratic formula. What, really? No. Or are you just being like positive? Like, yeah? Okay. All right, so unless you're Ada, I don't want you to do that. There's another way to do it. I hate quadratic formula. Because that stupid plus or minus, it's such a pain, right? Because you got to figure out what happens if I put a plus sign in. What happens if I put a minus sign in? And it's a pain in the neck, right? Okay. So if that happens, if you're trying to solve for the time and using this results in using the quadratic formula, I mean, you're welcome to use a quadratic formula if you want. There will be problems where that'll come up. If you want to do it that way, more power to you. But I don't like doing it that way. So here's what I usually do. What I will usually do is this. So you've got this information. The reason that it was easy this time was because VI was 0, right? You guys agree that if we wanted to, we could use that equation to find VF?
Yes.
And that equation is not horrible, is it? Now remember, when you use this equation to do VF, you're going to take a square root, right? What's the square root of 9, for example? Plus or minus 3. So take your square root and then decide if it should be positive or negative. You'll be able to figure it out from the context of the problem, right? If it's going up, it's positive. If it's coming down, it's negative. Good? Then, once you've got your VF, then you can find your time by using this guy. All right? So your options are either one long step using the quadratic formula or 2 little steps. Take your pick. This is the way that I will do it. Okay? If the VI is not 0 and you know the displacement, I will usually use this equation to find VF and then use this equation to find time. Clear? Questiones. Going once. Uh-oh. Going twice. Okie dokie. Cool. So why don't you guys use the last 15 minutes? Use those last 15 minutes to get started on the other half of 1.5 and or ask me questions on the first half of 1.5 because there were other questions here that I did not get to. All right? Save.